let's start learnifying. Shall we learnify? All right. So, they give you a blank opening exercise on the packet. They give you a blank space. I was so nice that I gave you graph paper. Okay? So let's, I'm a nice guy, aren't I? I'm going to put this on my, yeah. Do you see how far behind I am? Do you see how far behind I am? Imagine if I did that. All right, here's what I want you to do is, on one of these graphs, we're going to do the opening exercise. Next to the graph, I want you to do this. I want you to draw a table. Just like that. And we're going to do, let's go -4, -3, -2, -1, 0, 1, 2, 3, 4. So we're going to analyze my function, f of x equals x squared. I'm going to do it at the values of all the integers between and including -4 and +4. Got free books I got today? I got a lot of free books. Huh? No. No. I'm going to read these things. Especially this one. Isaac he's awesome. Anyhow, alright. When x equals -4, what is x squared? +16, right? How did Brandon get that, Abby? What is f of -4? So when x equals -4, what is f of x? The function is x squared, right? So what he did is he took -4, squared it, and got his value. So when x equals -4, y equals 16. Now, let's cut to the quick on this, shall we? What do you think f of +4 is? 16 as well, right, Nick? Because 4 squared is also 16. How about f of -3? Stephen Peterson. Yeah, so what is -3 squared? +9, right? And Christine, what would the value be if x was +3? What's +3 squared? +9, right? So let's fill in this table the rest of the way on our own. And then we'll meet again in 2 minutes. Actually, in 1 minute. It should only take us a minute to do this. And we'll see if we got all the same points. Did everybody get these without copying them from the board? All right. So what do I do with these?
Put them on your dang graph.
Put them on my dang graph. So Brandon's got an idea. So when x equals -4, where does x equal -4? I start at the origin, I go 1, 2, 3, 4 to the left. There is x equals -4. But when x equals -4, what does y equal? What does y equal when x equals -4? 16. If I'm counting by ones, can I fit that on my graph? No, so we're not going to worry about those two right now. Well, let's worry about this one. When x equals -3, what does y equal? 9. So what would the point be for that? -3, (9). Graph that point. So -3 and then 9. I think yours only goes up to 8. So go up one more. Eyeball that last one. That was a straight point. We're graphing these points.
I know, but how?
No. What point do I graph for this? Yeah. There you go. It's not imaginary. You're just eyeballing. You're estimating. All right. So, what about this guy? What's my point there, Michaela? -2, 4. Okay. Jeff, riddle me this. Do I even need to write these points over here? It's kind of Department of Redundancy department stuff, right? I just need to look at the x and the y and graph those. So everybody graph those points. So -2, 4. I went over left 2 and up 1, 2, 3, and 4. Beautiful. Now, draw a gentle curve to connect all the dots. Don't connect the dots with straight lines, but draw a curve. There you go. The longer you are in math, the better you will get at drawing parabolas, which will help you in all aspects of life. Brandon, that shape that you drew is a parabola. No. I suppose this. I suppose that's a donut, huh? Is that a donut? No. That's not a donut. That is a torus. That's called a torus. Donut. Donut. That's a torus. Hey, no, not a torus. No.
A four torus.
Not a torus.
Yeah.
A torus.
No, I'm thinking of top.
No.
It's a donut.
Not a donut. Alright, so when you do all the points, you should get something that looks, I'll do this in green, and I'll do it in a very thin line. How's that for a parabola? So, what are some things that I can see? What are some features of this that I can see? It's curved, right? Do I see any corners there? No. Do I see any jumps? Okay, so, two features of this. it's going up faster, but are there gaps in the parabola? Does it stop here and then jump up to here and then start again? No, it's smooth. It continues. We call it continuous. Okay. Another feature is it's smooth smooth, right? So it doesn't have any corners in it. But here's one thing. What's my line of symmetry? You guys went through geometry. The y-axis, right? The y-axis. Very good. Excellent. Excellent. Okay. And now on the graph below, so on this graph, we're going to do another graph and chart. This time it's going to be x cubed. We will do that, but bear with me for a second while I scale this to size. So, we're going to do x and a y. And then, let's do, because -4 didn't do us any good, did it? So let's do -3, -2, -1, 0, 1, 2, and 3. So now, here's what I want to ask. When x equals 0, what is 0 cubed? 0, right? So let's put that point here. Let's put a 0 in for y when x equals 0. How about when x equals -1? What is -1 cubed? Jordan? -1. -1 times -1 is 1. Times -1 again, -1. How about 1 cubed? 1 times 1 times 1 is 1. Okay. We're doing cubed. So I'm hearing some disbelief. So -1 cubed, right? That equals, can you believe they don't believe us, Jordan? -1 times -1 times -1. What is this? What is this? And that's 1 times -1, right? And then this is -1. Winner, winner, chicken dinner, right? All right. So how about -2 cubed? -8, right? Negative times negative is a positive, times another negative is negative. So -2 cubed is -8. And what about -3 cubed? -27. Good job, Jeff. -27. What do you think 2 cubed is? +8, right? And what about 3 cubed? +27. Good. It looks different, right? Now, check this out. We're going to have trouble fitting 27. Nice. We're going to have trouble fitting 27 on here. So we're going to count by threes. So this is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay? So that we can fit all this on there. So 0, 0, right? -1 is -1, so it's right there, right? If each square going vertically is 3, then it's a third of the square down for -1, -1, right? +1 is also going to be, oops, like this one. Why is it not? I don't even like that.
Just make it that bigger.
You tell how OCD I am? Alright, now for 2 and negative 2, I go down to 8. So 3, 6, 7, 8 right there, and 3, 6, 7, 8 right there. And then for 3, I go up to 27 and down to 27. So negative 3 goes all the way down to 27. Positive 3 goes all the way up to positive 27. Yeah, it does look like a slithery snake. Now, in a very gentle curve, I'm going to connect these dots. I'm going to go, oh.
Nice!
That's an awful curve, but you get the general idea.
Next problem.
No, mine's awful.
Next problem.
Hold on. What are some of the properties on this? What are the properties of this? Again, is my curve continuous? What does it mean to be continuous?
It's going back.
There's no jumps in it. There's no gaps. Is it smooth? Is it smooth, Ryan? Does this have any corners to it? No, it's smooth. Okay. Also, check this out. This one had an axis of symmetry at the y-axis. We call that an even function. Okay? We call it an even function because of that guy right there. So, that's an even function. What do you think we call this one? What do you think we call this guy? What's the opposite of even? Odd. And look at that. Now, here's my question. I didn't do this up above, but we'll go back to it. What do you think the graph of x to the 5th would look like? It'll look very similar to this, except what? It'll be steeper, right? It won't be wider. Well, think about this.
No. Yeah.
Let's do x to the 5th in blue. So when x is 0, it's 0, right? When x is 1, 1, and negative 1. When x is 2, what's 2 to the 5th power? What's 2 to the 5th power? 2, 4, 8, 16, 32. So let's be negative 32 and positive 32. So in blue, I'm going to graph x to the 5th here. And it's going to look like this. Oh, wait. No. Right there. And then I'm going to do red and do you see how it gets tall and skinny? It's going to get taller and skinnier. What do you think x to the 7th is going to do? Or what do you think x to the 7th would do? And it stretches out even more, right? So, let's look at the same thing over here. What do you think x to the 4th would do to this? It'd be, I'm sorry? Steeper, right? It'd stretch it out. Okay, good. All right. think I want to stop here. I want to stop here. All right, we're going to carry on tomorrow at exercise 1.